Why is Boltzmann's constant important for understanding entropy? Imagine trying to understand how tiny particles like atoms and molecules behave inside a gas or a solid. It's like trying to see the whole forest when all you have are individual trees. Boltzmann's constant acts as a bridge that connects these microscopic details to the big picture of how energy spreads out in a system. It's a tiny number, but it carries a huge role in understanding disorder. In thermodynamics, entropy is a way to measure how spread out or disorganized energy is in a system. Think of it like how messy a room is. More mess means higher entropy. Boltzmann's constant appears in the key formula for entropy, which is written as entropy equals Boltzmann's constant times the logarithm of the number of microscopic arrangements, or microstates, that match a particular macrostate. This formula shows that, as the number of possible arrangements increases, so does the disorder or entropy. For example, imagine a gas in a container. The particles can be in many different positions and speeds. The more arrangements they can have, the more disordered the system is. Boltzmann's constant helps us turn the count of these arrangements into a meaningful number for entropy. Without it, we wouldn't have a way to connect the tiny world of particles to the energy and disorder we see on a larger scale. In mechanical engineering, this understanding helps us analyze how systems transfer heat, how engines work, and how materials behave at the atomic level. When designing a refrigerator or a heat engine, engineers use the concept of entropy to see how energy moves and how much of it is lost or wasted. Boltzmann's constant makes these calculations accurate because it ties the microscopic world to the energy changes we observe. It also has units of energy per temperature, which means it helps relate the energy of particles to the temperature of the whole system. This is important because it allows us to predict how systems will respond when heat is added or removed. In short, Boltzmann's constant is vital because it provides the numerical link that turns the count of microscopic particle arrangements into the measurable property of entropy. This connection is what makes it possible for engineers and scientists to understand, analyze, and improve systems involving heat and energy. Without it, we would lack a clear way to connect the tiny particles' behavior to the energy and disorder we see in everyday life.